Okay, so I hope you can hear me. I'm always confused by microphones. Thank you very much for the invitation to give this first lecture of this very first edition of the Atlas seminar series. I hope you can continue it for many, many years to come. All right, so my lecture falls within the scope of landscape archaeology, and it means that it relies therefore on the premise that space and landscape are neither a passive backdrop for human activity, nor merely the physical environment to which people have to adapt. In the course of daily practices, human beings experience the world and they imbue it with meaning. In this way, landscape is a cultural and social construct. And if landscape is involved in shaping human experience and activity, it is in turn marked by human intervention. And as a result, landscape becomes an artifact that can be studied archaeologically. In the 1980s and 1990s, theoretical and especially phenomenological strains of landscape archaeology were skeptical, to say the least, as to the relevance of digital technologies such as GIS. Phenomenologists place the emphasis on bodily experience and human engagement to explore archaeological landscape. So really, it's not surprising that they would have fundamental objections against GIS, which represents space in a Cartesian, cartographic, and quantitative manner. It's the divergence between these two approaches that I try to convey with these two images. On the left is a photo that I took at Tripiti when I visited this area for the first time and discovered it through my body, my movement, and my senses. And on the right is a map in 2 dimensions, of course, and this map shows the location of the settlement and the tomb of Tripiti, as well as the viewshed of the tomb. The divergence between the phenomenological approach and digital approaches is also illustrated in this quotation by Christopher Tilley, who expressed clear dissatisfaction with any form of spatial representation and especially with digital technologies. This quotation is almost 20 years old, and whether or not one agreed with it in the first place, in the meantime, different evolutions have taken place in the field of archaeological GIS. GIS using archaeologists have tried to adopt a reflexive approach. They have worked towards grounding their tools and their methods into sound theoretical foundations, and new tools and methods have been developed that aim at modeling past landscapes in a less stereotypical manner. 2 themes have attracted a lot of attention in archaeological GIS, namely visibility and movement. The reason for such attention is twofold. On the one hand, visibility and movement are central to human experience of being in the world, and on the other hand, digital simulation gives the opportunity to increase the scale, the extent, and the scope of the study beyond the realm of what would be possible with phenomenological approaches. In this presentation, it's also on these 2 themes of visibility and movement that I would like to focus by examining the funerary landscape of early Bronze Age Crete. In particular, I will concentrate on just one tomb, and I will ask several questions in an attempt to understand the position that this tomb occupied in its landscape. For the purpose of this Atlas lecture series, it's not the conclusions that matter, but rather the methodology, the questions that are being asked, and the means that are deployed to answer these questions. This is what I will try to emphasize in this lecture. Different types of tombs were used in pre-palatial Crete, some of which are displayed on the screen. So we have circular tombs, rectangular tombs, rock-cut tombs, cyst tombs, and also clay containers. We also have rock shelters, caves, and so on. So many different types of tombs. And the tomb that we are going to talk about today is the circular tomb. Here it is. It's Tholos A at Apisokari. Circular tombs were the most monumental burial structures of pre-palatial Crete. The inner diameter of circular tombs ranges between 3 and 30 meters. Tholos A at Apisokari has a diameter of about 5 meters, so it's quite small compared to the largest tomb, which is at Platanos and which is 13 meters in diameter. Some circular tombs, as is the case of Thulus A at Apisokari, are associated with rectangular annex rooms. These circular tombs, they were used for collective burials. They remained in use for centuries and sometimes as long as a millennium. As you can see on the map, some of the circular tombs have been discovered in northern and eastern Crete, but most of them are actually concentrated in the south central region of the island. And it is indeed there that is located Apisokari over there on the northern foothills of the Asyrusia Mountains, directly overlooking the Mesera Plain. This Thulus tomb, Thulus A at Apisokari, was excavated in 1942 by Schulgendorfer, who published only a brief report about it. But about a decade ago, Georgia Fluda resumed the study with a view towards final publication. The monograph is almost ready and it will soon be published by Instap Academic Press. Thanks to Georgia Fluda, now we know that Thulus A was built during the early Minoan III period, so in the late 3rd millennium, and we also know that it was used for burials until the middle Minoan II period, so in the 18th century BC. There are two other Bronze Age sites in the area of Apisokari. The first one is over, no, it's okay. It's over there. It's a Thulus B. It's another circular tomb. It's located more or less 200 meters to the east of Thulus A. This tomb was built at the beginning of the early Bronze Age, which means at least 5 centuries earlier than Thulus A, and it continued to be used until Middle Minoan II, like Thulus A. And the second site that is located close to Thulus A is the settlement, which is there a bit uphill, 200 meters to the south of Thulus A. This settlement, according to current evidence at least, was founded at about the same time as Thulus A during the early Minoan III period. I would like to stress that the proximity between these 3 sites does not imply that they functioned as some sort of set. In the area, there may be other settlements and there may be also other cemeteries that still await discovery. And in any case, there is for the moment no evidence for settlement during the early Minoan I and early Minoan II phases when Thulus B was already in use. There are more or less 90 circular tombs that are currently known in Crete, but Thulus A at Apisokari is unique because of its topographic settings. Usually, Thulus tombs are built on flattish land, but it's not the case of Thulus A at Apisokari. As you can see over here, and hopefully also over here, the circular chamber is built on the bedrock ledge that slopes down towards the west. And the annex rooms, which are to the east, over here and over there, are on a higher level. That kind of configuration with a circular tomb that is built on a sloping bedrock with the annex rooms higher up is attested nowhere else. And the reason for that kind of choice clearly was not structural. It's actually quite the contrary. There are other spots nearby that would have been much more suitable to accommodate the tombs, but apparently the builder wanted to have Thulus A at that exact location. But why? Why was it so important to build Thulus A at that exact spot, even at the risk of jeopardizing the stability of its circular chamber and hence of its durability? I would like to suggest that visibility may have played a role, and I propose to examine 4 different hypotheses that all have to do with the visibility to and from Thulus A. So let's start. Circular tombs were monumental buildings, which makes it likely that they were intended to be seen. You don't build a huge building hoping that it's going to be hidden. But a meaningful question in terms of landscape studies is whether these monumental tombs were purposefully built in areas that afford high visibility so as to maximize their visual impact. To try to answer this question, I have computed what I have called local total viewsheds. On the screen, you see the local total viewshed of Thulus A at Apisokari, and I would like to take a little while to explain in detail how this was produced and hence what it means. A total viewshed is the sum of individual viewsheds calculated for the centroid of each cell of the digital elevation model. So you take the first cell of the digital elevation model, you define the centroid of this cell, and you calculate the viewshed of this point. Then you repeat the operation with the second cell of the DEM, the third cell, the fourth cell, and so on, until the last cell, and at the end, you sum all the viewshed, and you get that kind of image that will show which areas afford the lowest visibility, which is here highlighted in dark blue. So mostly there, there, and there, as well as the image on the screen. Oh, now we moved forward. Okay. Shows which are the areas that in the region are the most visible. They are in dark red, whereas the blue ones are those that are the less visible. So this is a very short explanation, and in reality, several decisions must be made when we calculate a total viewshed, and each one of these different decisions affect the question that is actually being asked. And I will spend quite a while explaining all these different decisions. The first decision that we have to make is the following. So do we want to model the visibility from the feature of interest or the visibility of the feature of interest? So if we put it in other words, it means, do we want to model the experience of an individual who would be standing by the feature and looking around, or do we want to model the experience of someone who would be walking in the surroundings, looking towards the feature that we are interested in? In our case here, what we wanted to do was to assess if the circular tombs of early Bronze Age Crete are highly visible in the landscape, which means that we have to model the visibility of the tombs themselves. And this will affect the next decisions that we're going to make, as well as the question that we're asking. The question that we're asking now is if the tombs were visually prominent. That is to say, do the tombs dominate the field of view of an individual moving in the area? In contrast, if we had decided to model the view from the tomb, we would be asking whether the tombs visually command and hence control the surroundings. The second decision that we have to make stems from the nature of prominence. Prominence is relative. Something is prominent in comparison with something else. And the word comparison is key here because we have to decide what the tombs should be compared to. Generally, the location of burial sites is influenced by the location of associated settlements. Indeed, it's quite unusual for a group of people to travel huge distances to build a tomb, especially if this tomb is meant to be used as a collective burial place. In this sense, burial sites can be considered local features, which is why I decided to compare the tombs to their own 500-meter radius neighborhood, and in this way study them in their local landscape. Every one of these decisions that I made can be contested. Maybe you don't agree, and then it means that you will not agree with my conclusions. If we decide to use this 500-meter radius neighborhood, our question now becomes, are the tombs visually prominent in their local landscape? So we're not dealing with the entire island of Crete, we're not dealing with the whole south central Crete, but we are studying the tombs in their own local landscape. Since we decided that we want to model the experience of an individual who would be moving around and looking towards the tombs, we have to add an offset of 1.5 meter, more or less, accounting for the position of the eyes of this individual who is walking around. Ideally, we would also have to consider another offset, which is the height of the tombs that we are looking at. But here we have a problem because the digital elevation model that we have corresponds to the bare topography. So we just have the terrain. We don't have the pre-palatial houses. We don't have the vegetation. So if on top of this bare topography, I was to add the size of the tomb, I would introduce a bias in favor of the tomb that would appear in my analysis more visible than they actually were. And this would make our conclusions statistically invalid. So to avoid overestimating the visibility of the tombs, I decided not to add an offset accounting for the size of the tomb. And this again changes the question that we are asking. Because of the question of this decision, our question becomes centered on the visual prominence of the tomb's location rather than the tomb itself. So now our question is the following. Does the location of the tombs afford visual prominence in their local landscape? And we have to make yet another decision, which concerns the viewing radius, which has to do with the visibility of the tombs, the limit of visibility of the tomb. So how far can a tomb be seen? And the limit of visibility of a feature depends on a series of factors, including the size of the feature. Unfortunately, we don't know how large the circular tombs were. We know their diameter, but we don't know their height. We will talk about this a little bit later, but in any case, this issue requires a bit of guesswork to guesstimate the size of the tomb. So we have to make, again, an arbitrary decision that maybe you disagree with. In any case, once we have decided on the size of the tombs, we can rely on studies of human visions, according to which a feature can be seen and recognized for what it is if it occupies at least 3 seconds of the visual arc. This angle of 3 seconds of the visual arc corresponds more or less to the size of the object multiplied by a ratio of 1150. This means, for instance, that for a tomb that would be 5 meters high, this tomb would be visible over a distance of 5.75 kilometers. And in this way, we reach the final question that we are actually asking by making this series of decision, which is the following. Does the location of the tombs afford visual prominence at the local scale in the eyes of an individual moving across the area from where the tombs can be seen and recognized? I do realize that my insistence or even obsession with these different decisions is pretty tedious, but as I have tried to demonstrate, each one of these decisions impacts the question that we are asking. If we had made different decisions and chosen different parameters, we would be asking a different question. The local total view sheds and the statistical tests of significance that we are going to discuss in the next minute will enable us to answer our starting question with either yes or no. And this means that the way that we formulate our question will strictly determine our conclusion. So this is why I obsess over these things that can look like small details. Once we have made all these decisions, we can finally start to compute the view sheds. The procedure is quite straightforward, but it's a little bit time-consuming. So in this case, I undertook the procedure for each symmetry of circular tomb, one by one. The example that you see on the screen is not Apistocari, it's a Marathocephalo. And for each of these individual burial sites, I calculated individual view sheds for the centroid of every cell of the digital elevation model within a distance of 500 meters. So these are all these black dots over there. Of course, I used the viewer offset and the viewing radius that had been decided upon previously, as I just explained. And then I used the size of the view shed of each of these points, which I returned as an attribute of the point, and then all these different values were reclassified in 10 ordered categories that each comprise 10% of the viewpoints. So class 1 will correspond to the less visible viewpoints, which are here in dark blue, whereas class 10 corresponds to the most visible viewpoints, which are in bright red. And from there, we can assign a value to the tomb that ranges from 1 to 10, and which corresponds to the visual impact of the tomb's location in its local landscape as seen by an individual who would be walking across the area from where the tomb is visible and recognizable as such. So we see that the tomb is over there. It masks the color, but we must be in a category 8 or 9, which means that the tomb of Marathocephalo is located within what is in the most visible part of the local landscape. Why did I bother normalizing the values of all the different tombs to get a value between 1 and 10? I did that because then I get a chance to compare the tombs, to plot the results on a histogram, and to determine whether we can observe a pattern that would be consistent between all these different tombs that we just studied. On the histogram here, the white bars represent the background values, which are the random pattern, or in other words, a situation in which the tombs would have been positioned without any concern for visibility. And the black bars, on the other hand, correspond to the distribution of the tombs in the 10 visibility classes. We see that the tombs are underrepresented in the lower categories here and overrepresented in the higher categories over there. And a statistical test of significance considered that, taken as a group, circular tombs are located in areas that tend to afford greater visual prominence in the local landscape than they would if they had been placed without concern for visibility. So in short, all these analyses, months of work and multiple decisions enable us to conclude that visibility seems to have played a role in the decision-making process that guided the placement of circular tombs in their local landscape. As they were visually prominent in their local landscape, the tombs were visually omnipresent to the people living in this area. The tombs contributed in this way to organizing and anchoring space, and they functioned as landmarks. Their role as mnemonic device was emphasized, as was also their role as a monumental materialization of the associated community and its past. This conclusion applies to circular tombs generally speaking, and it also applies in particular to Tholos A at Apisokari, because we see that the tomb was built in an area that gets a value of 9 on this local visual prominence scale. What's extremely interesting in my opinion, however, is that the most visible area of the local landscape is to the east and to the southeast of the tomb. So if the tomb had been built a little bit to the east or to the southeast, in the area that is highlighted in red over there, the tomb would have gotten a value of 10, which means that it would have been positioned in the most visible portion of the local landscape. So the analysis demonstrates that Tholos A was visually prominent in its local landscape, but visual prominence alone cannot explain why the tomb was built on this inconvenient sloping bedrock ledge. Something else must have triggered the construction of the tomb at that specific spot and not just a few meters to the east. So we can start asking additional questions. The next question I would like to examine has to do with the location of the settlement. Elsewhere in Crete, we can see that circular tombs tend to be intervisible with nearby settlements. And so we can wonder if it was the case at Apisokari. Only a small sector of the settlement at Apisokari has been excavated to the south of the rocky summit of the hill, so over there. But according to Yorgia Fruda, the settlement extended also in this direction around the rocky summit of the hill that is over there. To assess the visibility of Tholos A, here we must take its original height into account, which, as mentioned before, requires some guesswork. Indeed, none of the circular tombs is fully preserved, and actually the roofing technique that was used to cover these tombs remains uncertain. On the screen, you can see different hypotheses that have been tested by Kostas Papadopoulos. Tholos A at Apisokari is one of the tombs for which the hypothesis of a stone vault is quite possible. So maybe the tomb looked like something like this. But this still does not tell us how tall this tomb may have been. In Crete, we can find in some regions that kind of shepherd huts that are called mitata, and that are often cited by archaeologists when discussing the architecture of circular tombs. So, of course, no one is trying to imply that there would be some sort of affiliation between circular tombs on the one hand and mitata on the other hand. The idea is that a similar solution could have been found to face a similar architectural problem in similar circumstances. So far, 2 mitata have been studied by archaeologists, and in these 2 cases, we observed that the height of the building corresponds more or less to 90% of the inner diameter. And if we use the same ratio to guesstimate the height of circular tomb, we obtain a theoretical height of more or less 4.4 meters for Tholos A. Again, you can disagree with this. You can consider that there are no fundaments to this estimate, but at some point we have to make decisions. Otherwise, we can just not do the analysis. The map here models the visibility of Tholos A if it were indeed 4.4 meter high. I use the same color scheme as before, and therefore the areas that are in red corresponds to those from where the tomb is the most visible. So what is dark red correspond to areas from where the entire tomb, from the top to the bottom, is visible. Whereas areas in blue correspond to areas from where only the top of the tomb could be visible if indeed the tomb was 4.4 meter high. What we see here is that the view shed, according to the view shed, the Tholos tomb was visible from the settlement, at least only from the north and northwest edges of the settlement. Since there is a lot of guesstimation involved in deciding what is the size of the tomb, I tried the analysis again, this time increasing the height, theoretical height of the tomb and inputting a value of 6 meter, and we see the results that we get. Actually, there is not so much that changes, and we can conclude quite confidently that the tomb is poorly visible from the settlement, which leads us to conclude that the tomb was not positioned on this bedrock ledge so as to be intravisible with the settlement. The next, this is the view shed from the settlement, actually. So it's a cumulative view shed computed for all the different white dots in the settlement. And so it shows us which areas of the landscape are the most intravisible with the settlement. So we see that what's actually the most intravisible with the settlement is located uphill on the mountain, whereas the tomb at Tholos A in particular is very poorly visible from the settlement. So we can conclude that indeed the tomb's builder didn't try to ensure intravisibility between the world of the living and the world of the dead. The next scenario that I would like to consider is related to the use of tombs, and especially collective tombs, as territorial marker. The message here is quite simple. Our community is buried here, which means that this has been our land for a while and there is no reason for it to change. Visibility can play a role in affirming the territorial right of a community, at least the right of this community to occupy and use the territory. And indeed, if the tomb is highly visible, it serves as a strong reminder of the rights of the community to occupy and use the land, and vice versa. If the tomb visually commands the surroundings, it serves as a means to control these surroundings. So there is a role of visibility in asserting the right of the community to use and occupy a territory. In this context, I find it extremely interesting to note that today there is no intravisibility between the two circular tombs of Apisokari. So if you stand by Tholos A, you cannot see Tholos B, and vice versa. But if we want to test whether this was also the case in the past, we can rely on GIS analysis and specifically viewshed analysis to make the test and assess whether the two tombs could have been intravisible in the past when they were still standing. The map on the left shows how much of Tholos A would have been visible and from where. Again, we have the same colors as before. In blue are areas from where only the top of the tomb could be seen. Again, if it was 4.4 meters high, whereas areas in the dark red are those from where most of the tomb could be visible. And the map on the right shows you the same thing, but for Tholos B. What we see is that Tholos A stands outside of the viewshed of Tholos B, and Tholos B stands outside of the viewshed of Tholos A. So we can conclude that even when the two tombs were still standing, they were not visible from one another. What I find quite remarkable is that not only the two tombs are concealed from one another, but also their viewshed overlaps very little, at least at the near distance. This map on the screen shows which area, from which area the two tombs can be seen. So in yellow is the area from where only Tholos A can be seen. In red is the area from where only Tholos B can be seen, and in orange you see the area from where both tombs are visible. At the very near distance, we note that the two tombs can be seen simultaneously only in this small bit which corresponds to a low stone ridge between the two tombs. Sorry. All right. So it's only from this area that you could see the two tombs at the same time. And now look at the different map. If this tomb had been built just 50 meters towards the east, the visual pattern would have been completely different. In that case, we could observe that the view sheds overlap a lot. The two tombs are intravisible, and in contrast, there is this big area here that becomes visible from none of the tombs. So what's happened when the builders decided to install Tholos A on the sloping bedrock ledge is that they associated the two tombs with their own visual niche, at least within a distance of more or less 400 meters. And if we follow through with the idea that circular tombs may have marked territorial rights, there are two different ways to interpret this visual pattern. According to the first interpretation, the two tombs could have been used by distinct communities, which would have been in competition with one another, and which would have delimited what they considered to be their territory by means of the visibility from and to their visual tomb, their monumental tomb, sorry. But there is an alternative scenario, which would be that during the early Minoan III period, the community that was associated with Tholos B would have decided to build a second circular tomb so as to increase its visual control over the surroundings. So here we have two opposing interpretations for the same visual pattern, but in any case, what these maps clearly show is that the location of Tholos A in this bedrock ledge resulted in this area to be highly visible, which would not have been the case if the tomb had been built just a little bit to the east. This area that is now visible from Tholos A is at the interface between the Mesera Plain and the foothills of the Asterousia, and it is also in this area that the modern asphalt road starts to ascend up the Asterousia mountains, and this leads to the last question that I would like to address here, which is whether Tholos A may have been positioned to be intravisible with communication networks. Answering this question involves modeling optimal paths across the area, and here it is. In archaeological GIS, least cost paths are often calculated to delineate the least costly path, either in terms of time or in terms of energy, between archaeological sites. One serious limitation of least cost path analysis is that this method tends to assume that each of site would be connected by means of a direct route. So if you look at the map here, you can guess that some of the paths are repeated between different pairs of sites, but nevertheless, the network is quite cluttered. And this is not what we would expect in reality. In reality, we would expect a network with main segments going in different directions, with secondary paths diverging, branching off this main path to lead specifically to the archaeological sites that we are interested in. So archaeologists have tried to develop different methods to model movement, and one that I like a lot has been developed by Fabrega Alvarez and is called Focal Mobility Network. This is the Focal Mobility Network. This is the means to approach movement towards a destination without an origin. So this method of focal mobility network highlights the most cost-efficient paths that lead to the destination from anywhere in the study region. This was an extremely smart idea by Fabrega Alvarez, and it's a very simple procedure that is fast and easy to implement. In fact, it combines cost distance analysis with hydrological tools. The workflow is highlighted here, and it's pretty straightforward. It consists in calculating an accumulated cost surface, as one would do when trying to calculate the least cost path, But then, instead of proceeding with the least cost path analysis, we perform hydrological modeling on this accumulated cost surface. So we calculate the flow direction on the cost distance, and then on the product of the flow direction analysis, we calculate a flow accumulation. And this is what we get. We get a network of paths that irradiates around the central site in a way as if water was flowing through an irregular funnel and leading down to the bottom. Focal mobility networks can have many different applications. One of them being that it gives us a chance to examine the accessibility of archaeological sites. But in my opinion, the procedure becomes even more interesting if we repeat the operation for various sites and then sum the resulting mobility networks, because then we can get an idea of natural corridors of movement across the entire landscape and in relation to known archaeological sites. So this is exactly how I created this map. I calculated individual focal mobility networks for each one of the symmetries of circular tombs, which are these white dots. Then I summed the result and I calculated the density of path. And eventually I reclassified the values to distinguish between a major paths, which are in black. These are the paths that are created in a majority of the individual focal mobility networks. And we can distinguish these major paths from the secondary paths that are in blue and the minor paths that are in red. This method makes it possible to get rid of the paths that exist in only one focal mobility network, which means that the map you see on the screen actually outlines natural corridors of movement across the landscape. If you see this tomb, for instance, here, or this one, there is no path that leads specifically to the tomb. So this gives us an idea of general patterns of movement across the landscape. You can see that the model does not perform well at all in flat areas like the Messera plain. So this is completely useless. It's full of paths. It does not tell us anything anymore. But the method works very well for mountainous areas like the Asterosia or the lower foothills of the Psiloresis. And lucky us, Apesokari is located at the foot of the mountain in an area for which we have good results with this method. So near Apesokari, we see this major path that leads from the Messera plain up to the mountain. We see it over here. And also we see another path, which is between a secondary and minor, that leaves this major path and leads up the mountain. And if we zoom in again and clean a little bit the image, we see that this path passes right below Tholos A, which is here, before going up the hill and reaching the settlement before it continues towards the south in the mountain. If we put the viewshed back on the map, we see that Tholos A is well visible from this path. And this is not the case of Tholos B, and it's not the case either of the settlement, since if you remember the maps that we saw before, from the settlement we have very poor intravisibility with this entire area, actually. Being highly visible from this path, Tholos A could have functioned as some sort of waypoint along patterns of movement, and among others, it could have functioned as a waypoint showing the way towards the settlement, which was poorly visible from the Messera plain. So in this way, an individual coming from the Messera plain would have walked up, visually encountered the dead members of the community, and only then reached the living members of the community. So the location of Tholos A at Apesokari, and generally speaking, the location of any human-made feature, is the result of a compromise between different criteria that reflect different concerns of the associated community. By examining the position that Tholos A occupies in the landscape, we have a chance to try to identify some of the criteria that led to the location of the tomb, and in this way we can gain new information about the relationships that the living constructed with their dead, and about the roles played by funerary rituals, cemeteries, and the dead. The location of Tholos A at Apisokare is really puzzling because it stands on this bedrock ledge that slopes down towards the west. There was room to install Tholos A on flatter ground to the east, but apparently this location, just a few meters to the east, did not meet the criteria that were deemed the most crucial by the community that built the tomb. Vision is the main sense by which human beings comprehend space, and it's therefore not too eccentric, in my opinion, to wonder if visibility may have played a role in the decision-making process that guided the location of Tholos A on this apparently inconvenient sloping bedrock ledge. The viewshed analyses that we looked at in this presentation have demonstrated that Tholos A was highly visible in its local landscape, but visual prominence alone does not justify the location of the tomb, because Tholos A would have been even more visually prominent if it had been built a little bit further east. Installed where it was, Tholos A was not intravisible with the settlement or with Tholos B, so we can conclude that intravisibility with either one or both of these sites did not guide the placement of Tholos A on its bedrock ledge. If visibility matters indeed guided the location of Tholos A on the sloping bedrock ledge, it seems that the goal was to ensure intervisibility with the area that is located downhill to the west, which is circled in red. And in doing so, the aim could have been to visually control territory or to make the tomb well visible from a path leading up towards the settlement and across the Asterusia Mountains. And actually, those two different interpretations, they are not incompatible. The tomb could have functioned as a waypoint along local and regional communication networks, while at the same time supporting the territorial claims of the associated community. There are interesting implications in terms of the Minoan archaeology here, because the late pre-palatial period was characterized by demographic growth and hence increased pressure on land resources. And this could explain why the community of Tholos A made strong territorial claims. But the late pre-palatial period was also characterized by an intensification of regional and intra-regional interactions, which would relate to a growing interest in communication networks. But this is a story for another day, or at least another conference, because my goal in the context of this Atlas lecture series was to give a glimpse into how GIS can be used to study past funerary landscape, or at least the experience of past funerary landscapes. In particular, I have tried to show what kind of hypotheses can be tested and how the GIS analysis must be tailored to address the intended question. Every decision that we make in terms of viewing radius, feature offset, and viewer offset must be carefully thought out so as to match our hypothesis, our question, and our goal. Many different questions can be asked using viewshed analysis and GIS, generally speaking, and often we will not stop after one viewshed. More often than not, we will compute many viewsheds. The game is almost endless, and actually it's quite fun, and so it's rather easy to get lost in it. Thank you for your attention.